Hello everyone and welcome to this video. My name is Kleena and today I'm going to be taking you through the solution to question 5 from this Leaving Cert higher level paper, and this question is based on functions and it's worth 30 marks. In question A, we're told that the function f is defined as follows for x as an element of R. So we're told that f of x is equal to 1 all over 5x squared plus 7, and we're asked to find the derivative of f and to give your answer in its simplest form. So whenever I'm given a fraction like this, I always find that it's easiest to rewrite it as follows. So f of x is equal to 5x squared plus 7 to the power of minus 1. Okay, so that's the same as saying 1 over 5x squared plus 7. So now let's find the derivative of it. So we're going to use the chain rule, okay? So I'm going to be left with f dash of x is equal to, bring this down here, so we have minus 1, 5x squared plus 7 to the power of minus 2 because we reduced the power by 1, and we multiply that by 10x. So now we want it in its simplest form. So how are we going to do that? So 5x squared plus 7 to the power of minus 2x is the same as 1 all over 5x squared plus 7 to the power of 2. Okay, so we have minus 1 by 10x by 1 over 5x squared plus 7 to the power of 2. Okay, so we are going to have minus 10x all over 5x squared plus 7 to the power of 2. That's our final answer, so I'm going to draw a nice neat box around it. And for this answer here, you're going to get a total of 15 marks. Question B tells us that the function g of x is defined as follows. So g of x is equal to tan of x over 2 by ln of x, and we're asked to find the value of g dash pi over 2. Okay, so that's the derivative of g of x, and you fill in for pi over 2. Give your answer in the form a plus ln b, where a and b are real numbers. So I'm going to use the product rule for that because we're multiplying two things against each other. Okay, so I'm going to let tan x over 2 equal to u, and v is going to be our ln of x. So then we find du dx and dv dx. Now, the product rule is in the log tables, but some of you might know it off by heart just because you might be using it a lot. It's going to be u by dv dx plus v by du dx. So let's start with the tan of x over 2. And let's go to our log tables to find how to find the derivative of tan. So with tan here, to find the derivative of tan of x, it's sec squared of x. Okay, so the derivative of tan of x over 2 is going to be equal to sec squared of x over 2, and then we need to include also the derivative of x. Okay, so of x over 2, which is going to be a half. Okay, and then for ln of x, the derivative of ln of x is just going to be 1 over x. And that rule is in the log tables as well if you need to find that. So now let's start multiplying them. So we have u by dv dx. So that's going to be u is tan x over 2 by dv dx, which is 1 over x, plus v, which is ln of x, by du dx, which is sec squared x over 2 by a half. So now what we need to do is we need to fill in for x is equal to pi over 2. So we have tan of pi over 2, and that's multiplied by 1 over pi over 2, plus ln of pi over 2, sec squared pi over 2, and that's multiplied by a half. So first of all, let's use our calculator to work out the tan of pi over 2 over 2. So make sure that your calculator is in radian mode for this. So I'm going to press tan, and then I'm going to have pi over 4, which is the same as pi over 2, and that gives me 1. Okay, so if that's 1, we're just left with 1 over pi over 2, which can be written as 2 over pi. So I'm just going to rewrite that as 2 over pi now to make it easier for myself. 2 over pi plus, and then we have the ln of pi over 2, which again, we can work out using our calculator. Okay, and that gives us a longer number. So for the moment, I'm just going to keep going with ln of pi over 2 because it's actually simpler that way. So plus the ln of pi over 2 And then I'm going to bring this half in front here, in front of my ln pi over 2, because now we need to work out sec squared of pi over 2 over 2, or sec squared of pi over 4. Now, there is no sec squared button on the calculator, so you have to use the rule, which is on page 13 in the log tables. Now, I think that this question is particularly hard. Putting in a sec squared for a Leaving Cert question is really tough because it's not usually on the course, it's not usually examinable. So they wanted you to use this rule that's on page 13 of the log tables, which is that sec squared of a is equal to 1 plus the tan squared of a, okay? So I'm going to rewrite sec squared of pi over 4 as 1 plus the tan squared of pi over 4, okay? And when you work out that in the calculator, you can see that if you have tan pi over 4 squared, you get 1, okay? So we're going to have 2 in this bracket. So now what we have is, we have 2 over pi plus half ln of pi over 2 by 2, okay, because that's 1 plus 1. Now when you include the half here, when you multiply half by 2, you just get 1. So the answer you're going to get is 2 over pi plus ln of pi over 2. So this is the final answer, and for this question you're going to get a total of 5 marks. Now, as I said, I think that this question is actually really difficult and that maybe it shouldn't have been put on this paper. I think a lot of students might have struggled with it, but that's the way to do it anyway. It is good to know the sec squared rule, that it can be written as 1 plus tan squared a, but I can imagine that a lot of students this year were struggling to find sec squared on the calculator, which it's not on the calculator. Now in question C, we're told that the diagram below shows 3 sets, A, B, and C, and 2 functions, f and g, where f of A goes to B and B goes to C, okay? So we're asked to find the value of g of f of 3. So when you're looking at a question like this, the first thing I do is I ask myself, okay, what is f of 3 first? And you can see that the f of 3 is this world sign here, okay? So I'm just going to draw a little world sign. So now, what is g of the world sign? And g of the world sign goes to w. So the answer is g of f of 3 is equal to w. Now the next part asks us to explain why g, as b goes to c, is injective but not surjective. So why is it injective? If a function is injective, that means that no element of the function that it's going to is used more than once. So C is our output, and no element of the output is used more than once. So that means that it is injective. It wouldn't be injective if one of the elements of the output was used more than once. So the answer is no element of the output, or of C, is used more than once. And now the second part asks us, why is it not surjective? It's not surjective because there is one element of C, of the output, that is not used. And for this question, part 1 and 2, you're going to get a total of 10 marks. Okay everyone, so that's all for this question. I hope you found this video helpful and that it might have cleared up anything that you were struggling with. Thank you all very much for listening. I'll see you in the next video.